Hello, continuing in our series of Introduction of Earth Science, we're going to do a lecture on the view of the Earth. So, in your Cornell note papers, just follow, please, for me. You can pause at any time, of course, as we move through the material so you can catch up. So, let me zoom in a little bit and let's get started. The lecture, a view of the Earth. We're going to try to answer the essential questions of this, basically to be what are the major spheres of our Earth, what are the main parts of our solid Earth, and how are continents positioned where they're at, and the major features. So we're answering some essential questions. First, what are the major spheres of our Earth? Next is what are the main parts of the solid Earth? And then how have continents positioned? Okay, so how have continents positioned? Now let's start with the spheres. And so if we do spheres, there's 4 of them. So spheres, there's 4 major spheres. In our planet, we'll change colors. And first one is the hydrosphere. The hydrosphere is the water portion of our planet. Hydro means water. It's the water portion of our planet. It's the water portion of our planet. Next sphere is the atmosphere. And this involves the air and gases or gaseous envelope around our planet. So hydrosphere, atmosphere. 2, 3 would be the geosphere, the solid Earth. Geo means land or rock. Geosphere is the, in quotes, solid part of Earth. And then finally, all living things, which is the biosphere. The biosphere. In the biosphere is all life on Earth. And it's also a reference to all the ecosystems that sustain life. Okay, key in all of this, of the major spheres as we describe our planet, is how the Earth is an integrated system. So this is an extremely important part that you need to understand. So once we describe the spheres, the water, the air, the solid earth, and the biosphere, all of them are integrated, and this is the concept that you need to grab. And so if I draw, I'm going to use a pencil to draw on the left-hand side the earth, draw an earth there. I'm going to circle the four spheres around it to indicate how they interact. So here is the hydrosphere, the biosphere, the geosphere, and the atmosphere. So if I draw here, I don't know, North America, Central America, South America, here's our planet. And I'm going to go ahead and color this as land. And I'm going to color just so over into the ocean blue. Okay, here is the ocean. So here's our planet, nicely described there. And this is the hydrosphere. I'm going to abbreviate it hydro. This one, the biosphere, bio. This one, the geosphere, geo. And then the atmosphere, atmo. Like that. What you need to understand then is that there is a relationship from the planet to each one of them, like this. I'm marking that in red. Like that. But more important than that, you also need to understand that there's relationships between each. The geosphere and the biosphere interact with one another. So the biosphere and the hydrosphere, the atmosphere and the hydrosphere, the water and the air, and likewise the air and the solid earth. So you have that kind of relationship around as a integrated system. You also, of course, have the biosphere and the atmosphere also relating to one another. So you have an arrow that goes between them, and the hydrosphere and the geosphere likewise in the same way. So you end up with a diagram that looks kind of like this. And one of the key things you need to understand is that the Earth, and I'm going to label it underneath it, that Earth is a system. Yeah, okay? Earth is a system. You need to understand that. All spheres are integrated. All spheres are integrated. Okay? Copy the best you can, and then you can pause as you move through the material as we work through the lecture. Now, the next thing I need you to do is look at understanding the solid part of the Earth. So we're going to look at the geosphere. And I'm going to do some drawing on that. So here's the geosphere. Here's the geosphere. And what I'm going to do in this case is I'm going to draw the planet as best as I can. I'm not perfect. And then I'm going to go ahead and put a vertical line to the center of the Earth. And then I'm going to do a cutout of it so you understand that this is a cutout of our planet. Now, what I'm going to do is kind of like shade this as best as I can. I'm going to shade this using this big fat pencil. I'm going to shade this And sorry, I got interrupted there for a second. Okay, so you understand that this is the globe, and I just took a quarter of it out. So I'm going to erase some of this stuff so it doesn't look as messy. Then I'm going to label the interior. So what I have here is from the center of the planet, I have an inner core that goes like that. Then I have an outer core like that. Then I have the mantle that follows. And right here, this doesn't look quite round the way I want it to, more like that. But right on the edge of that is the crust. I'll try the crust. So let me label it. So this would be the inner core. This would be the outer core. This would be the mantle. Inner core, outer core, mantle, and this would be the crust. Okay, so that's kind of the structure of the geosphere. You need to be familiar with it. I use a term when I'm doing lectures and stuff like that to kind of highlight some things for the students. And I use a symbol called an ojo. An ojo in Spanish means eye. So I'm going to go ahead and use this here. So ojo means pay attention. Okay, so ojo means pay attention to that and that as important parts of this brief lecture. Now in the back, what I'm going to do is basically complete the thickness of each one of these layers, give you a little bit more detail on that, and then basically address the how have the continents positioned themselves with plate tectonics. So let me switch it over to the back. And I'm hoping, okay, so this is what we're going to call the structure of the Earth. And once again, let me zoom in. I'm going to label it up here, structure of the Earth. Structure of the Earth. I'm going to go ahead and use a ruler. The diameter of our planet is approximately 6,371 kilometers. So I'm going to use basically 1,000 kilometers. And so I'm going to do about 6 centimeters, 6 centimeters, a little over 6 centimeters. And to get to the diameter, and again, a little over 6 centimeters, 63 is what I'm looking for, so to show a quarter of the planet, so I can show you the structure of our planet. So what I'm going to do is I'm going to draw an arc as best as I can. I just kind of like did a freehand sketch, and then I'm going to show you what I'm looking for. First of all, this is 6,371 kilometers. Okay, 6,371 kilometers from the center of the Earth to the edge. You need to know the radius of our planet. And then what I have here is about 1,200, a little over 1 centimeter is the inner core, and then 2,200 or so the outer core, and then about 2,200 or so for the lower mantle. So let's do that again on the other side. You see what I'm saying is about 1200, so I'm going to mark about 1 centimeter and 2 millimeters, plus 2 millimeters, then 2 centimeters and about 2 millimeters to do the encore. And then the lower mantle is another 2200 approximately right there. So those are our markers, if you will. So on this, I'm going to go ahead and attempt to mark it like that. Not the best, but there it is. Okay, so what we need to understand is that here is the inner core. Inner core approximately 1200 kilometers. The outer core approximately 2200 kilometers. The lower mantle approximately 2200 kilometers. 2200 kilometers. The upper mantle approximately 600 kilometers. And then of course the crust on the outside. And in terms of the crust, we can look at two things. One is continental crust. So if this is the crust, what I want to do is I'm going to draw a little bit of a continent on top of it like this, then an oceanic crust, which is thinner, and then another continental crust here. So I can label it continental so the thickness varies whether you're in the continent. So from right there to right there, that thickness is approximately 30 to 40 kilometers. The oceanic crust, on the other hand, is much thinner. From right there to right there is oceanic crust, and that's approximately 5 kilometers, much thinner. Of course, you have an ocean sitting on top of it. So do me a favor and copy the best you can this. Use a ruler again to be able to do the measurements. You have to be familiar with that. And then finally, the last thing that we have, let me switch the page over so you can see it, is how have the continents been positioned. So the way I'm going to be doing this is in the plate tectonics. Plate tectonics. You have two types of forces on the Earth. Destructive and constructive. Destructive would be things like erosion that basically wear down mountains and erode things. Constructive would be mountain building, volcanism, that kind of thing. There's a couple of forces. So what I want to wrap up with is the theory of plate tectonics, which says the theory of plate tectonics, and I'm sure you've heard this in middle school and have worked at some things in your classes, but plate tectonics provides a model to explain, how earthquakes and volcanic eruptions occur and how continents move. There's much more that we'll have that in the future. So do me a favor, and we're wrapped up with the lecture. So we have basically 2 pages. Thank you.